Hey guys, so welcome back from spring break. This is the first video I'm doing since I got back from spring break where I have a new grandbaby who's pretty stinking cute. I hope you all had a great break such that it was. Just letting you know, I have graded, commented on everybody's assignment that has been turned in over spring break, and I will start commenting all of the ones I'm getting now soon, and I will keep you updated on that progress. So what we're going to do is we finished up 5.3. There's a chapter quiz, mid-chapter quiz in Schoology that you can take, and we're starting 5.4 today. And we will start today doing our 5-minute check, which will be a little bit different. I'll give you each a little bit of time to solve the problem, then I will go over the answer so that we can keep up the review, because there will be, at the end of this unit, there will be a unit test. What that unit test looks like, I haven't decided quite yet. It just won't be as big as what we do at school, but I want to make sure that you're understanding the concepts and making good progress, and that's kind of where I'm going with this. So I'll do a review packet, which is not really a review packet, but you'll get a review worksheet that you can work on, and then we'll do a unit test, but I'll talk more about that later. Let's jump into the presentation. So hang on a second, I got to get to... All right, here we go. I'm starting with a little picture here. I went on a walk with my husband the other day, and we walked for about 4 miles. And back when I was the leadership teacher, we did a Kindness Rocks project, and we painted rocks and put them around the harbor. And they left positive messages for people to see, and just like a pick-me-up when you're out and about. So if you and your family or your friends get together and want to create some rocks like this and put positive messages. My favorite was Chin Up Buttercup. That would be a great idea. And there's the picture of what the video looks like. If you go on YouTube and search the Kindness Rocks Project, you'll be able to see how it originated and what it's about. So with that said, let's move on to the actual math. Hopefully you'll enjoy the rocks and maybe paint one. That would be fun. Here we go. Okay, so we're heading into 5.4, and that is sum and difference identities. And what you're going to need is you're going to need your cheat sheet, and you're going to need your unit circle, but we'll do that after. Well, you'll still need the unit circle for what we're getting ready to do now. So make sure you have those out. So if you have to pause the video before we move on, go for it. We're starting on question number 1 of the 5-minute check. Okay, here's question number 1. Remember, it's for all values of x. That's why the 2n pi is on there. So go ahead. I'm going to pause the video. I'm really not going to pause, but I'm saying I'm going to pause because I want to give you guys a chance to pause the video and solve the problem. So go ahead and pause. And go ahead and solve. Okay, you should be done now. So let's look at the solution. This is the solution worked out. And sine x equals negative root 3 over 2. If you look at the unit circle and you find the y values where negative root 3 over 2 would be, which is in quadrants 3 and 4, you will find that, let me make sure my pen is working before I jump into this and try to circle stuff and it doesn't work. Okay, you will find that in quadrant 3, the answer is 4 pi over 3 plus 2n pi, and in quadrant 4, it is 5 pi over 3 plus 2n pi. Okay, so hopefully you understand that. That's a pretty easy one. All right, let's go on to number 2. You are now going to pause the video and solve this one as best you can. Okay, now that you're done with this one, let's move on to the answer. The answers are right here. I actually did my diamond method up here. And I broke up I broke up the middle term into these two. This one and this one. And then I factored by grouping. So I took a 2 cosine x out, which left me with a cosine x plus 1. I took a 1 out, which left me with cosine x plus 1. And then here are the 2 factors, which I solved down to cosine x equals negative 1/2, which is true at both 2 pi over 3 and 4 pi over 3. And then cosine x equals negative 1 is true at pi. Okay, and you don't have to check these because you did not square them. So let's move on to number 3. Number 3, go ahead, pause the video and try this one, but I'm going to give you a little bit of a hint because right now you have two trig functions. So I would start by changing the cosine squared x to 1 minus sine squared x. Now, go ahead and solve. Pause the video and solve. Okay, so now you're back with me, and this is the answer for number 3, all worked out. Again, the diamond method. Again, I showed you this part. Okay, as I work it out, I distributed here. Then I moved everything to the right side of the equation because I don't like to have a leading term that's negative. Then I factored by grouping, and I came up with these two factors at the end, which are the same. So that means sine x equals 1/2, and that happens at pi over 6 and 5 pi over 6 because it's in quadrants 1 and 2. Okay, so hopefully this is all review for you. That's why I'm kind of going fast through the explanations of the answers so I can get to the content of the new lesson. All right, let's go to number 4. Number 4, again, a little hint here before I have you pause the video. You're going to want to move, I think I ended up moving cosine over. Then you're going to end up squaring. And remember, when you square, you have to check your answers. So go ahead and pause the video and try that one. Okay, welcome back. Here is the answer for number 4. Sorry, it was on slide 10. So I moved the cosine over, and then I have 1 minus cosine x, but we can't do anything with that because it's not a Pythagorean identity. So we square both sides, which makes this sine squared x, and this makes this a quadratic cosine squared x minus 2 cosine x plus 1, because remember you have to FOIL it. Then I move everything from this side to the right. That's an arrow I'm trying to draw. And then you have over here, because the 1 goes away, 2 cosine squared x minus 2 cosine x, which when you factor it, 2 cosine x comes out. You have a cosine x minus 1. That solves to cosine x equals 1, which happens at 0. And cosine x equals 0, which happens at both pi over 2 and 3 pi over 2. Now, that means it could be this answer. But remember what I said. It could be D, but you have to check your answers on this. So I happen to know that pi over 2 works, and I happen to know that 0 works, but I want to show you why 3 pi over 2 doesn't work. So I'm going to go to the original. I'm going to say the sine of 3 pi over 2 plus the cosine of 3 pi over 2 equals 1. Well, if you look at your unit circle, the sine at 3 pi over 2 is negative 1. And the cosine at 3 pi over 2 is 0. Well, negative 1 does not equal 1. So therefore, 3 pi over 2 is not a solution. So our correct answer is actually A. So, all right, let's go to number 5. That's our last one, and probably the easiest almost of all of these. So go ahead, pause the video, and solve that one. All right, nice job. Let's go and look at the answer for this one. This one's pretty easy. It solves down to sine equals 1/2, and that's positive in the first and second quadrant, which is why I have those answers circled. So pi over 6 plus 2n pi and 5 pi over 6 plus 2n pi. Now let me see. I probably didn't touch on this one. Okay, the difference here and why you don't have 2n pi on number 4 is because of this statement right here where it says from 0 to 2 pi. It's on the interval, so you don't put 2n pi after it because it just wants to know what is happening one time around the circle. Okay, now we're done with all of our lovely 5-minute checks. So we're going to talk about this. You're going to use sum and difference identities to evaluate and to solve trigonometric functions and equations, okay? And to do that, you will need your cheat sheet, and this is the information from the cheat sheet that we will be using. It's one block on your cheat sheet. You will also need your unit circle. These are very important, so have all of those out. And then let's jump into the next problem. Okay, so I put up here in the corner the unit circle and the sum and difference identities just so we don't have to jump around the presentation as much. They're kind of tiny, but you'll be able to see them well when you're looking at your own sheets on the side. So if you see here, it says find the exact value of cosine. Oops, I must have the eraser on. Hold on. I don't know why. Okay. It says find the exact value of cosine 75. Exact means it's going to be in simplest radical form. But cosine 75, that's not on our unit circle. That's why we have sum and difference identities. So I need to, in this case, I could use any combination of subtraction or addition on the unit circle to come up with angles that equal 75 degrees. But what I'm going to do is go with the easiest, because I'm sure most of you have figured out what two angles in the first quadrant add up to 75 degrees. Well, that would be 30 and 45. So I'm going to choose, I'm going to state that cosine 75 degrees is the same as cosine of 30 degrees plus 45 degrees. Now, this is where your unit circle and your cheat sheet come in handy. So what I'm looking for is what form in this sum and difference identity box, which one am I going to use to actually solve this problem? Well, I have a cosine 30 plus 45, so I'm going to be using the cosine A plus B one. So that means I'm going to say cosine of 30 degrees plus 45 degrees equals cosine 30 cosine 45 minus sine 30 sine 45. Sorry, it's running over there. I'll make it look a little bit better down here. I'll move down a little. So that means, so now what I have to do is I have to look at the unit circle to figure out what my actual cosine values are. So I'm going to look over here at 30 degrees, and the cosine there, we know that the cosine is the x value, so it's root 3 over 2. So that means we have root 3 over 2. Then I'm going to look at the cosine for 45 degrees. Well, that's the x value again, so it's going to be times root 2 over 2. And then we have a minus here. Then I'm going to look, this says, I know it's kind of messy, but it says sine 30 and sine 45. So I'm going to go and look at the sine of 30, which, let me erase what I circled there because you can't see it. The sine of 30 is 1/2. So we're going to get my pen back. Okay. And make sure it's on the right pen. Okay, good. So the sine of 1/2, or the sine of 30 is 1/2. So I'm going to go 1/2. And then the sine of 45 is also root 2 over 2. So I'm just basically going to multiply these. Root 3 times root 2 is root 6. And 2 times 2 is 4. Minus 1 times root 2 is root 2. Over 2 times 2, which is 4. The nice thing about this is then we merge it into one fraction because we have a common denominator. So we make it root 6 minus root 2 all over 4. And that is actually your final answer. This is exact. So you're not going to type it in your calculator for a decimal. It's exact and it's in simplest radical form. Okay? So that's it for part A. Let's go take a look and see if the answer is the same on the answer slide. Root 6 minus root 2 over 4. Are we right? We are correct. So yay, we did good. Okay. So now we're going to go on to part B. And I have this down here a little bit so I can move it around. Give myself a little bit more room. I don't know if I can move this one. Let me see. I have it locked. Let me unlock it. Okay. Okay, unlock. I'll move it up a little bit. Okay, that way it's not so much in the way. Because this one's a little different with tangent. Okay, now I'm going to lock this one back up. Okay. All right. So on tangent, it's a little different when you're looking at your unit circle. I have to find things on tangent that add up to 11 pi over 12, but all of the denominators for all of the angle radian measures are different. We have 3, 4, 6, but we have to find combinations of ones that can be converted to 12, which add up to 11. So let me kind of illustrate that a little bit. So, and I'll erase this later, but I want to start with it. So first off, I have pi over 3. Or well, pi over 6 is our first actual angle. So let me go back and get my pen because I keep forgetting to do that. Okay. So pi over 6, with a denominator of 12, we would have to multiply both by 2. So 2 over 2. Okay, so that would give me 2 pi over 12. If it's pi over 3, okay, we're going to multiply both by 4. That'd be 4 pi over 12. See, so far these two would add up to 6 pi over 12, which is not going to work for what we're needing. So I'm going to erase that for now. Okay, back to my pen. All right, next thing is pi over 4. Well, I have to multiply both of those by 3, so that would give me 3 pi over 12. I still don't have enough that add up. I need 2 that add up to 11. Well, I know that 2 of these would be 8 pi over 12, right? So maybe rather than the pi over 3, I go look for 2 pi over 3. Okay, well, 2 pi over 3 changed into a denominator with 12, I would have to multiply by 4. So it'd be 8 pi over 12. Well, 3 pi over 12 and 8 pi over 12, they both equal 11 pi over 12. And that's what I'm looking for. So right now down here, I'm going to write those so I remember them. It's pi over 4 that I'm working with, and 2 pi over 3, because I'm going to erase all of the rest of this. So let's erase that. Okay, so I've erased that, and now I'm going to figure out which identity I'm going to use. We're doing tangent, so tangent, oh, again, I got to get my pen, keep forgetting, sorry. Okay, tangent 11 pi over 12 is the same as tangent pi over 4 plus 2 pi over 3. Okay, so that means I'm doing a tangent A plus B. I need to look at my unit circle, so I'm going to be using this particular identity down here, okay? And this takes a little bit more room to write. That's kind of why I move things around. So tangent pi over 4 plus 2 pi over 3 will be the same as tangent pi over 4 plus tangent 2 pi over 3 over 1 minus tangent pi over 4 times tangent 2 pi over 3. Now, we are using this information to come up with our tangent of our pi over 4, and we're using this information to come up with our tangent 2 pi over 3. Again, you'll be able to read it better if you're using your own unit circle. So, remember, tangent is y over x, okay? So we're going to go and look and see what our tangents are. Well, the tangent at pi over 4 is pretty simple because the y over x there would equal 1, because root 2 over 2 over root 2 over 2 equals 1. So that means we have 1 plus. And then the tangent of 2 pi over 3 is going to be root 3 over 2. So let's see here. Tangent 2 pi over 3 will be root 3 over 2 over 1 over 2. Okay? And the 1/2 is negative. But remember, we can get rid of the 2's because they have the same denominator. So that means my tangent of 2 pi over 3 equals negative root 3. So that's what I'm putting into the equation here. Okay. And then on the bottom, it's going to be 1 minus 1 times negative root 3. Okay? So that equals 1 minus root 3 over, and then we have 1 times negative root 3, which is negative root 3, but it's a negative negative. So we're going to have 1 plus root 3. Okay, now I'm going to go to the next screen because we need a little bit more room to work because we still are not done with this. So just a second here, I'm going to get my pen back. I don't know how that disappears sometimes, but anyway. This little area here, we're not done. And that's because we have a radical in the bottom. So we have to rationalize the denominator. So I'm going to go to the next slide where we have some room. Okay, so that was 1 minus root 3. Okay, why are you doing this to me? Okay, thank you. I don't know why I'm thanking technology, but whatever. Over 1 plus root 3. Now, if you remember, when we have a situation like this where we have a constant and a radical in the bottom, I have to actually multiply by its conjugate. So think about that for a second. What would the conjugate of 1 plus root 3 be? It would be, for some of you who have already figured this out, it's 1 minus root 3. So 1 minus root 3 over 1 minus root 3. So I have to FOIL the top. So 1 times 1, let me do this here. 1 times 1 is 1, okay? Negative root 3 times 1 is a negative root 3. And a 1 times a negative root 3 is negative root 3. And then a negative root 3 times a negative root 3 is a positive 3. Okay, and on the bottom, it's pretty easy. It's like difference of squares, sort of. We don't have a middle term because positive root 3 times 1 and a negative root 3 times 1 will cancel each other out. So we just worry about the 1 times 1, which is 1. And then a negative root 3 times a positive root 3, which is minus 3. Okay, so now we're just going to combine like terms and see what it looks like. Up top, I'm going to have 4 minus 2 root 3. That's combining those like terms. Over 1 minus 3, which is a negative 2. So what I can do now, I'm still not done because I know I can simplify this farther. I can actually get rid of this whole negative 2 by factoring a negative 2 out of the top. So negative 2, what's left in my parentheses? A negative 2 plus root 3. If you get confused on what I did there, just redistribute this negative 2. Let me change it to blue so you can see it. Redistribute it. That would equal that, and that would equal that. Does that make sense? So I'm going to get rid of those little blue lines because we don't need them. So right here you see that this can cancel out. Okay, so it's going to equal negative 2 plus root 3. Now you'll see over here I was scribbling out the answer because I didn't want you to see it before we actually got done. So now what I'm going to do is I'm going to erase this and see if we're correct. Yay! We're right! Woo! So with a little celebration just because I can, if I could do it faster. Yay! Does that make you happy? Makes me happy. Okay, that's really one of the toughest ones. So now I'm going to go on to the tangent. This is our last one before we actually get into the homework. I'm going to pause the video and give you a chance to actually solve this. And a little hint, there is no tangent 15, so you're going to have to figure out two numbers on the unit circle that will equal 15. And most likely, since 15 is lower than anything on there, you're going to have to use a subtraction. So I'm going to pause the video for now, and I'm going to let you guys have a chance to work on this problem. Okay, so let's work this one together, because I am not going to give the answer until we're done solving it. So hopefully you came up with the same numbers I did. I am going to say that tangent, okay, I did it again. The eraser's still on there. Hold on. Gotta get the right pen. Okay, tangent 15, and I did tangent, oops, hang on. Tangent should be inside the parentheses. So tangent 15, okay, stop it, equals tangent 45 minus 30. That's what I did. Okay, so tangent of 45 minus 30 equals, and I did not put, hang on a second here. Okay, so hopefully you have your cheat sheet out because you'll be doing a little better than I am right now. Hold on. If you're looking at your cheat sheet, then that means that it's going to be tangent 45 minus tangent 30, okay? Over 1 plus tangent 45 times tangent 30. So tangent 45, I'm going to come down in this area because it gives me a little more space. Tangent 45 is 1 minus, and tangent 30 is going to be root 3 over 3. Okay, and that is because at tangent 30, you would have 1/2 over root 3 over 2. Those cancel, but then you have 1 over root 3, and when it's rationalized, it would be root 3 over 3. Okay? Then you have the bottom, we'll go back to the equation here, 1 plus 1 times root 3 over 3. Okay? So that gives me, and I'm going to change, let me change to a different color pen here. I'm going to change this 1 to 3 over 3 in both spots so I can merge the fractions, okay? So you'll see what I'm saying right now. Okay, we'll go back to blue. So I'm going to have 3 minus root 3 over 3. And 3 plus root 3 over 3. And same denominators cancel out. So we have 3 minus root 3 over 3 plus root 3, which you probably figured out. We now have to multiply by the conjugate. So 3 minus root 3 over 3 minus root 3. So this one on top will equal 9 minus 6 root 3 plus 3. And that's because we have a 3 root 3 and a negative 3 root 3 and a negative 3 root 3, which creates the negative 6 root 3 in the beginning, or in the middle. This one, again, you're just doing 3 times 3, which is 9, and a negative root 3 times a positive root 3, which is negative 3. So that takes us, to, let's go here, we're running out of space, but this will be 12 minus 6 root 3 over 6. I can factor out a 6, which gives me a 2 minus root 3 over 6. These two cancel, so 2 minus root 3 is your answer. So those of you who picked D, you are correct. So hopefully you understood through that, because I actually have quite a mess going on here in the work, but this little line will separate what I did from one line to the next, so you can see it. All right, that is it for the work on this particular problem. Let's go look and see if D is correct. D is correct. Yay! I get so happy when I'm right. Well, when we're all right, because I'm sure a bunch of you got that correct. Okay, last slide is about the homework. Okay, it says, I'm out of here. I love this little kid. That's so cute. So chapter 5.4, page 341, problems 1 through 6 all. They will be posted on Schoology. Again, please take pictures. Please take pics and upload them onto Schoology. And there will be more new information coming. They want us to put more information out, so I will get more lessons ready as fast as I can. So I miss you all, and I hope you're all doing well, and we will talk soon. And again, if you have any questions or if you want to do a Zoom meeting to get additional help, please let me know. I will set up an appointment. In fact, that's why I'm talking fast right now, because as soon as I'm done recording this, I'm going to go meet with 3 students on Zoom to help them. So take care. Love y'all. Have a great one. Bye.